Problem 7.6. In a slider crank mechanism, the connecting rod AB is 750 mm long and the crank OA is 150 mm long. The end B moves along a straight line passing through O. Trace the locus of a point P 300 mm from A along the rod for one revolution of OA. The slider crank mechanism. This mechanism is explained as follows. The end A of the connecting rod AB is connected to the crank OA, which rotates about O. The other end B is attached to a slider which slides along a straight line. The locus of A will be a circle and that of the end B will be a straight line. The locus of any other point, say P, on the connecting rod will be neither a circle nor a straight line and can be determined by the following steps. 1. By assuming various positions of the crank end A. 2. By obtaining the corresponding positions of the end B. And 3. By locating the position of P on the lines joining the first two positions. Finally, a smooth curve drawn through the located points will be the locus of P. The curve obtained is known as coupler curves. Let's see the stepwise procedure to draw the above path. First, draw a circle which is the path of point A. Then, divide circle into 12 equal parts. From the center of the circle O, draw center line which passes the end point B of the rod. With center 1 and radius AB, cut the path of B at point B1. Draw a line joining 1 and B1. Here we have to trace the locus of the point P on the rod at a distance from point A. Now, again with center 1 and radius PA, cut the line 1B1 at point P1. Obtain other point in similar manner. Then, draw a smooth curve through these points. This curve is the locus of point P. Observe that the distance B1-B7 is the travel of the slider and is equal to twice the length of the crank. This length is known as stroke length. Note the movement of slider is not uniform with that of the crank end A. This completes the procedure to obtain the required locus of any given point using slider crank mechanism.